I'm going to describe very briefly how a program written by Pat Winston works. This program is supposed to learn by example, and it learns in a rather different way from previous programs that attempted to do learning. It needs a good teacher. The teacher comes up to the machine, which contains a vision system for describing things, and I give it an example, for example that, and say, this is an arch. Well, the machine describes it, and the description, the structure that the machine builds up inside its memory is something like this. There are 3 objects found by the vision system. They're all identified as blocks, and it notices certain relations between these objects. For example, that this one supports that, and this one supports that. These are the legs of the arch, and that's the top. And notices a lot of other things that I haven't got time to describe, such as that this block is standing up, and this one is lying down, and so forth. And it records that as an arch. It's the only thing it knows about arches so far. Then we give it another example. Let's show it that. And we say, that's not an arch. Well, the machine can only do one thing with the picture itself. It has to describe it, and its description looks something like this. To you and me, this doesn't look very much like an arch at all, but in some sense the description is quite similar. It still has 3 objects. This one is lying down, these are standing up. They're all blocks, but there's a very large difference as far as the machine's descriptive structure is concerned. The relation between the blocks of this one supporting that and this one supporting that is missing. Well, since the machine has been told it's not an arch, what it has to do is change its description of arch so that it won't think that's an arch anymore. And what can it do? It can say, well, it must be supported. So this is its first step in learning what the teacher is trying to get it. It now knows that it must be supported. Let's give it another example. We tell it that's not an arch, and again the machine has to describe the scene, and its description now looks something like this. Again, the description is very much like the description of all the others. There are 3 blocks. There is support here, but there's one more relation that wasn't there before that has quite a high priority in Winston's program, and that's contact. These 2 blocks are touching one another. And again, the teacher tells it the answer, in this case, that's not an arch. The program says, oh dear, I must change my description of arch so that that will be rejected. And since the most important difference is this contact relation, it puts in a new relation, which now is must not contact. And you see it's getting a pretty good idea of what an arch is. Already it's a structure of 3 things, which must have the right support relations, and they must not touch the 2 supports, which means that there'll be a hole in it. The program doesn't have the idea of hole, but it has a pretty good practical equivalent. Finally, the teacher might give it a 4th example, this, and say, that is an arch. And the description of this structure agrees with the description that's been building up, except for one small detail. The top thing is no longer a block, it's a wedge, and the program has to say, I'll accept things that are wedges as well as blocks, and that's pretty easily changed by saying this can be block or wedge, or in the actual program it generalizes and says that can be a prism. Well, the point of the program is that it doesn't learn so much a little bit at a time as in the traditional reinforcement theories of learnings, which work very well for rats and very badly for people. But for each example, the machine jumps to some sort of conclusion, learns a new relation, and it can learn very fast. It's learned a lot from 4 examples. On the other hand, it takes a good teacher. If you gave it misleading examples where there are many differences between the things it's seen and the new things, then it will be at sea. There'll be a lot of differences that it could put in here, and it won't have any good way of deciding which differences to represent in its final result.